Hello guys, today we are going to welcome to this course Introduction of Foundation of Mathematics. So under this course we'll be treating a series of subjects of, of topics which have about 15 in number. So we treat elementary set theory, binary relations and operations, mathematical logic, polynomial expression and equations, and also inequalities, that polynomial inequalities. We'll be talking of quadratic equations, indices and logarithm, permutation and combination, binomial theorem, the number systems, sequences and series, sorts, matrices, complex numbers, trigonometry, partial fraction, and geometry. So these are introductory course that will help you throughout your stay, especially those that are going into mathematics, science field, maths, physics, computer engineering. So these topics will help you as you go on. You will treat them in more details, help you to understand other topics and other courses. So it's important to take them serious. So today we'll be talking first of all of set theory. So our first topic today will be set theory, which is the elementary of set theory. So, so let's go straight to it. So set theory. A set is a well-defined collection of connected objects, taking in disregard their order, that is the order of these objects. The objects you have, they are well-defined, they have similar characteristics. So is that characteristic that we are talking of is what that is what where their connection is. So let's take for instance, so examples of sets. Let's take for instance now we have a set of even numbers. So we have number one now. We have a set of even numbers x, such that x is an even number. So this is a set now. So let's say 2, 4, 6, 8. Dot, dot. That it means it continues. The triple dot there means the set continues. So we're having a set of even numbers. This is an example of set. The connection there is even number, that they are even numbers. So we have another set again, a set of another example, a set of vowel numbers x, so yeah, sorry, vowel letters. X is a vowel alphabet. So the connection is there is that all these elements of all the members of this set, they are vowel alphabet. So this is a set of vowel alphabets. They have a set of musical instruments, a set of musical instruments. We have what, maybe a keyboard, a drum, a flute, violin, and so on. There are many. So all these are sets. A set, we say, a set is a collection of well-defined objects. That these objects are well defined, that their connection are given. So no matter how they look, okay, you can say objects in a house, no matter how they look disconnected, if you are going to group them in a set, they will have a connection, and then we are not going to consider their order. So in this our set of even numbers now, we can say 10 comma, then we can, oh sorry, we can say 12, comma, you can now say 10. So we are not going to consider their arrangements. The arrangements are not in any way affecting the set. They are just this thing. We just say okay, we can say maybe numbers now they are arranged automatically, but if we look at our our musical instrument, there's no way we can say a keyboard supposed to be before a drum, supposed to be before a flute. So we are not going to consider their order. So that's what a set is all about. Just a collection of well-defined objects. So now, where can this set theory be applied? We are studying something, we have to know where it can be applied to. So set theory is applied in different areas. Set theory is applied in maths. Other maths is applied in, you can say, in mathematical structures such as graphs, such as vector space, such as abstract algebra, when we talk of number systems and analysis, mathematical relations. So all these places now where sets can be applied in mathematics. And let me make a note. The application of sets mostly has to do with uh, applying it in topics that can help in, that is, set theory is, it helps to understand other topics better. On its own, you can't find a concrete application of set. You can say set as a theory, as a topic, helps in understanding other topics better. So in computer now, set is applied in such as let's say arrays. In arrays, in linked lists, sets, in vectors also in computer. Computer is all about maths. In machine learning, so that is MI, and in other aspects too, and also in statistics too. Statistics deals with data, so and this set is about grouping data, and then business, in engineering, and then etc. Also in daily life, when we say, okay, let's take for instance now our musical instruments. We have a set of musical instruments. We have a set of types of chairs. We say group the chairs together according to their types. We have set of bulbs. So in their day-to-day activities, number of students in a class, number of students offering a particular course. So that is a set. So those are the applications of sets. So now let's move from there forward. Now that we know the application of sets, because it's important to know the application of sets, and we'll be able to know why we are studying sets. So because if you don't know what you are studying and why you are studying it, where you can apply it, sometimes you will not see the reason of learning that thing. So it's important to know why we are studying sets. So we can see that set is applied in every area of our lives. So move from there, we'll move to this. So these are the number of sets we are going to be using throughout this course. We're using sets in a set of, shall not actually throughout this course, but we're using a set of prime numbers and a set of um, vowel numbers. So representation of sets. What are the ways sets can be represented? So that is the next topic that will be. So now these are the ways you can represent a set. If they say you should write a given set, how are you going to represent it? So a set, though there are two methods of representation of sets. The first one will have the enumeration method. So like in our example here, we have P and we have B. So in this first set, you have enumerated them. So it's about listing the elements of the members of that set. So like we have like 1, 2, 3, 4, 5, 6, 7, 8. We have 8 members of this set, and they are all listed out. So that is this are prime numbers now listed. So we say enumeration is about listing the members of the set. So these are prime numbers. Now we have listed them out. I will say x is a prime number from 1 to 20. So these have been listed out. So this is one method of representing it. The next example there is 5, the 5 vowel letters of the alphabet, A, E, I, O, U. So, so now this is a method of a way of representing sets by listing them out. And the next method we have here is the descriptive method. So here we describe the the set by giving the connection between the, so remember we say a set is a connection of well-defined objects. So we give the set out by describing those, what makes it, those connection, what makes each member to be qualified to be in that set. So now next topic we'll be talking about is the names, um, set notations. We're talking about set notations. So now the first set notation we have here is the name of the set. So most of the times for a one word set, a one word name for the set, it mostly begins with a letter. So let's take for instance this our set now, say P, it begins with a capital letter. It always has a capital letter for a one word set. Or let's say A, capital letter. So the name for a one word set is uppercase. So a one word set name is uppercase. Let's take for instance A equal to, is a set of 1, 2, A, C. And we have P here, which is the example we have here. P is the capital letter, and B we have B here, capital letter. So now the next set notation we have here is what? The Greek, I don't know what the name of this symbol, but it means in set, it means what? Element of, is read as element of. So from here now we have what? We have two. Two is a member of. So we'll be calling it member. Sometimes I mistakenly call it set element, but since I've not introduced it to elements, we'll be calling it member. So here 2 we'll say is an element of what? P. So we read this as what? Element of. We have another one, we have E is an element of what? B. So now that is the the name of this symbol. And then we have the next and this, we have what? Not an element of. So this symbol now is read as not an element of. Okay, now we have what? Z, not an element of what? Of B. And Z is also not an element of what? Of what? B. So this symbol not an element of, mind you, is not E. It's a Greek, I think it's a Greek letter that is written as this, not this. Mind you, don't write it as this. This correct, this wrong. So this is how you write it. So that's the meaning of the symbol. If you see it in other sets anywhere, that's the this one. So the next that we are going to talking about is the next notation. That is number 4, not number 5. Let's make a correction. Number 4. So now this one that look like C now is read as what? Subset of. Okay, so let's make a subset now and let's call it S. Let's make a set now. S is what? Let's say S is 5, 11. And remember we said the arrangement does not matter. 3. So that is an example of arrangement does not matter. So if we look at this now, at our example here, we'll see that S is a what? Subset of what? P. So that is how it's read as. So we'll see that this is 5, mind you. This is 5. So we'll see that this is a set, and we can pick this set out of, this set is gotten out of what? P. So we'll say that what? S is a subset of what? P. Okay, if we have a set now, let's say, if we have another set, let's say W. Okay, we have 2, we have 4. So now, no, not that example, but we can still use it from our first example here. So let's say what? Let's name this set here. Let's name this set here C. So say what? W is what? A subset of what? C, capital C, uppercase C. So now we see that what? Our set C is what? A set of what? Even numbers. And our W here is also what? A set of even numbers. But all the elements of what? W can be found in what? C. So that is a set. That is a subset. A subset is a set is a subset of another set is a set in which all the members of that elements of that set can be found in the what? Other set. That is S is a subset of P because all the members of S can be found in what? P. And S is a proper or S is a proper set because S is a proper subset because at least one, okay, so we are saying what a subset is. We said what? A subset is a set where all its elements can be found in what? The other set. That is, S is a subset of P because all the sets in S, all the elements in S can be found in what? P. So now, S is a proper subset because at least one element in P, which is what? A prime number. Here we have more than one element. At least one element in P cannot be found in S. So it's a proper what? Subset. So that is it. So now W also is also a what? Proper subset because all the elements in W cannot be found in what? In S. Where in C, where C is an element is a set of even numbers. So we have S6, 8, 12, and 10. They cannot be found in what? In W. So moving on to the next listen. So our next symbol is what? This is read as what? Not a subset of. So now a set, let's say st, okay, t is equal to 5, 18. Yes, let's leave it at that. So now t is a set of 5 and 18. So this set now, we say c what is not a subset of what? P. As you can see, c is not a what? Subset of P because we can find 5 in 18, but 5 in P, but we cannot find what? 18 in what? P. So now the next symbol we have there is what? This. So we have superset of. So we have that what? This is a superset of. So if a superset is the set where the subset is gotten from. So now we have that P is what? The superset of S. So say S is a set of what? 5, 11, and then 13, right? So now we'll say that what? P is a superset of what? S. And we have the W, W is equal to what? A set of 2, 4. And C is a set of what? prime numbers, so, even numbers. Sorry, C is a set of even numbers. So C is a superset of what? W. This is where we are getting our C from, our set C from. So now moving on to the next symbol. So if we have this cancel there for the others, why don't we have four supersets? So now for superset we have the what? This symbol is read as what? Is not a superset of. Okay, so we have that, we had that T is equal to a set of 5 comma 18. Okay, so now we have that what? P is not a superset of what? Set T. And also from here we can say P is also not a superset of what? Set what? B. So now those are the this involved quick tips. Well, see this my, okay, let me put it well. This is my right hand, this is my left hand. Remember in secondary school, yeah, in primary school, when we're taught greater than, less than, greater than. So we're bringing it here too. We said that one. Let's start from this one. So number one, we have five. I have 4 tips here for you to quickly remember if it's confusing you. Remember in primary school, because that's when it was introduced, the less than symbol. So you can bring it here to what? To say our left hand. By the time we fold our left hand, we get what? The less than symbol. So bringing it here, using that same terminology, by the time you fold your left hand, you get your what? Your subset. Less than subset left hand. That's when you fold your what? Your left arm. Right? Then two, we have greater than. So if we have greater than, we have our superset. These are what? Right arm. So number three, then we have is not. This cancel, we have this. So if you remember our inequality sign, so this will say what? A not. These are for not symbols. You see that they are strike through. And then you have again another way you can remember an element of the symbol. We have that what? Our element, the beginning is the symbol is looking like what? Looking like E. So this we will say we have the name to be what? Read as an element of. But like I said, this is not what? This is not E. It is what? I don't know the name. So let's move on. So those are quick tips that I used to remember. This when it was confusing to me, I used them to be able to remember what each listen stands for. So now we're going to move on to two types of sets: finite and infinite. Infinity has no end. Finite has an end. So those are the two sets we are going to be looking at now. An infinite set and a finite set. So now, a finite, a finite set is one. Let me remove this paper. Uh, I don't know if we'll still be using that. A finite set is one whose members are countable. You can count them. Okay, like a mass set. A mass set you can count, like a typical mass set has, wow, so a typical mass set has about eight members. So we have the ruler, no need to list them now. So it has about 8 members, so it's countable. So we have an element of E, a set of E here, that is a set of what? Even numbers. we have another set here, a set of what? The letters, and in this case we are referring to the letters of the English alphabet. No space there to write it down. So now, that is the first type in this class, is the finished set. They will say a finished set is a what? A set whose members are what? Countable. Then the next set is what? A set, that's the infinite set, is a set whose members are uncountable. So you cannot count them. So we have what is, let's say C, a set of what? Complex numbers, X, such that X is a what? Complex number. So I just remember. So I just remembered under set notation. Let me say this before this. We have a last one, which is, that is number 9. We have this symbol or this symbol. So that is what. So this is read as such as, such that, sorry, such that. So now we have been seeing it in our listen, so but it's the column we have been using. So like here now, this a typical, this is an example. C is a set where X, such that X is a complex number. So that is the reason. So we have another symbol. So this symbol 10 is what? The braces. So these are the braces, but this is not, these are the braces. So they symbolize that that is a what? A set. So this is read as such that. So now back to our listen. So we have that what? We have the finished set and the infinite set. The finished set are what? The set of countable, the members are countable. Infinite set, the members are what? Not countable. So we have a set, under the infinite set, we have X. We have a set C, where X, such that X is a complex number. So we have another set, let's call it D, where X, that is 1, 2, 3, 4, 5, comma, dot, dot, dot. That is triple dot. So this triple dot symbolizes that that set is a what? Is a what? Infinite set. So this set means that it continues. We have 1, 2, 3, 4, 5. You can say this is a set of real numbers. So now, or natural numbers, or whole numbers, counting numbers. So that is a what? An infinite set. So now the next we move on to is what? Equality and equivalence. We have equality of sets and equivalence of sets. So now, under this set, we have, let me put it this way, like this. Sorry for the too much moving of papers. So equality and equivalence of sets. Equality of sets. Two sets are equal if and only if every member of A is a B and vice versa. So we have a set A equal to 1, 2, 3, and we have a set what? B equal to 1, 2, 1, 3. So in set, the repetition does not also matter because 1, 1. So now all members in set A are in what? You can find them in set B. So you can say set A is equal to what? Set B. So this is our symbol for what? Equality. A equal to B. Our symbol for equality is what? Symbol is the equal sign. That is the equal sign. So now, it's two sets are equal if and only if every member in what? 1 is in what? Is in B. And every member in B is in what? A. So set A and B are equal. So now they are equivalent when, okay, let's have another two sets again. C equal to, let's say 2 comma 3 comma 4, and then we still have set what, A equal to 1 comma 2 comma 3. So now set C is equivalent to what, set A. This is when they both have the same number of what, elements. So C has 3 elements and A has what, 3 elements. So we say what, set C and A are equivalent, and our symbol for equivalent is this. So that's our symbol for equivalence. So now we move on again. So all these are terms and terminologies. Set theories has terms and terminologies where we can use them for to understand other further this thing, just like every other topic. So we have the next topic. We have the words difference of two sets. So the difference of sets A, that is A minus B. So the symbol here is, so say the difference of two sets A and B are sets, are elements present in A and B and not in B, sorry, and vice versa. So the difference of two sets A and B, the difference of sets A and B are elements present in A and not in B. Then we can ask him the difference of two sets B and A are elements present in what, B and not in what, A. So our symbol for difference is what, minus. So that's our symbol, which is this. So now we're having two sets again. Let's list two sets. A is equal to 5, 10, 15, 20, 25, 30. And then we have B is equal to 4, 6, 8, 10, 20, 30. So now the difference of these two sets now, A minus B, is a set of what? Elements present in A and not in B. So now elements present in A and not in B, we have what? 5 is present in A and not in B, so we have 5. 10 is present in A and B, so 10 is out. 15 is in, because you can't find 15 in B. We have 20. 20 can't be, okay, it's found in B. We have 20 there. We have 25. 25 is not found in 20 is not found. 20 is found in B. We have 20 in A and B, so we'll cancel it out. 25 is found in A but not in B. 25, and 30 is found in A and in B, so 30 is not in. So we have 5, 15, and 25. So these are what? Elements found in A and not in B. That is A minus B. So the difference of A and B is what? 5, 15, and 25. So now we have again another difference between set B and what? A. So let's do that. So now we have 4 now. 4 is in B but not in A. So we have 4. 4 goes in. 6 is in B but we can't find 6 there. So 6 also goes in. 8 is in B but not in A. So 8 goes in. 10 is in B and in A. So 10 is out. 20 is here and here out. 30 here and here out. So we have, so that's the difference of two sets. The difference of set A and B are elements present in A and not in B. Difference of set B and A are sets present in B and not in A. So the next topic we are going to look at again is types of sets. So we are going to look at 3 types of sets. So we have 3 types of sets here. We have the universal set. So we have the universal set, and the symbol is what? This, I don't know the name, but it's not you. No, that is not you. So this is how you write it. This is an art class. Yeah. So this is how I write it. That is your symbol for this. And also in that is the symbol we'll be using for our universal set throughout. So a universal set is a set that contains all elements under consideration. So a set that contains all elements under consideration. Like, let's take for instance now, we have, let's take our A and B. So if you this, you will see that we're considering A and B. So the universal set of what A and B will say is what? All, let's call it all real numbers. So this universal set, we are considering 5, 10, 15, 20, 25, 30, 4, 6, 8, or whatever, blah blah blah. But we can find all of them in what? Our universal set. So that is the universal set. It contains all elements under consideration. So the next one is what? Our null or empty set. So a set that does not have any element at all. So let's look at this one. Elements, let's say prime number from 2 and above. Even numbers that are prime numbers from 2, from 4 and above. Or let's say, I'm sorry, let's put it this way. Okay. Okay, X is a set of what? It's a set of even numbers above 4 that are prime numbers. But all even numbers above 4 are what? Divisible by 2 and itself, and 1. So our x is what? Is what? If we start to list them, we'll find that we'll have a what? Empty set. So now x is a what? Empty set. So that's an example. So x, and the symbol is what? This. We'll not write anything inside, or this. So that is the symbol. But it's not equal to what? It's not, don't ever you make the mistake of writing this in, because it's not this. But this, correct, correct, wrong. If I have my red marker here, I would have used it to marking. I'm grading myself now. But that is the symbol for what? Empty and what? Non-missing. So a singleton set is a set that contains what? One element. Let's say maybe a set of A. This is a what? Singleton set. So those are the types of sets. So in this, today we've considered a series of topics. So by next class we'll look at algebra of sets, intersection of sets, union of sets, complements, and the rest. So see you next class, and make sure you do these exercises just for revision of what we planned today so far. Thank you.